Good morning, everyone. Welcome to the STEM lesson. We'll begin with Unit 16, Electricity. The schedule of the day is, first, we look at what is electricity and its uses. That's a very familiar topic. Next, we'll look at what are electromagnets and how it works, what are its uses. Lastly, you'll have to do two experiments, try it out at home. One is maglev train and another is rising ghost Halloween experiment, for which the link is provided in your Google Classroom. Now, I want you to do the experiments, record yourself, okay, videotape yourself, and I want you to post them in Google Classroom. And when you do all that, you get 10 stickers each. In this unit, we look at what are the use of electricity. All of us are familiar with what electricity is and how and what are the uses, and we do use electricity in our everyday day-to-day life and activities. Now we'll take a step further and we'll see how using electricity we can convert the magnet into electromagnet. And what is the strength of electromagnet? Is the electromagnet same as an ordinary magnet that we have, or is it a lot stronger? And why do we have to make electromagnets? What are its uses? So we'll look at electromagnets in detail. In this slide, we look at the use of electricity. Just imagine going a day without electricity. That could be just next to impossible, right? We could initially get started off without having to use electricity, but as we progress later, we will realize how electricity is an integral part of our everyday life, and it's just impossible to move around without using electricity for a long time. Here in this picture, there are some of the common uses of electricity, like the electricity, it gets converted into light as an output when we use electric lamp. When we use, say for example, a fan, electricity gets converted into wind. When we use the speakers or the phone, it gets converted into sound. So the electricity that we all know, the output can be different according to the sources. It could be sound energy, it could be light energy, it could be heat energy, or it could be magnetic energy as well. Now this magnetic electricity has this magnetic effect is used in many electrical appliances that we use in everyday to-day life. Look at the picture on your right on page 51, magnetic effect. Now we'll talk a little bit about what is a magnetic effect and what is a magnetic field. Now everyone knows what a magnet does, right? It just some materials are magnetic materials, not all materials are magnetic, and it sticks to certain material which has magnetic property. Now, the Earth has a huge magnetic field because the core of our planet is filled with molten iron. So there's a large field that protects the Earth from space radiation and particles, such as solar wind. When you look at tiny magnets, they're working in a similar way. All tiny magnets, they have a tiny magnetic field working around them. This unit will learn how to take our normal ordinary magnet and convert it into electromagnet by running electricity to it. It's important for us to know what are electromagnets and how do electromagnets work. Now, I want you to click on the link below and watch the video to know what are electromagnets, what is its functions, and how simple electromagnetic magnets can be constructed. In this page, we look at how electromagnets are constructed. I think 2 to 3 P6 classes must have done this bus kit wire experiment, and they should know how to create a circuit right? We have a battery which has a potential electric energy, and when the battery is connected to wires, and when the wires are connected to an output such as the electric bulb, and when the connections are perfect, you get to know the electricity is flowing. Like, how do we know the electricity is flowing through the circuit? Of course, we have the bulbs light up, and we can tell that the electricity is flowing through the circuit. If now we don't have bulb as output, we could have some other output, such as in basket wire, we could produce a sound. When we move the loop of wire through the wire, we could create this sound. Before we talk about magnetic materials, it's important for us to know that not all materials are magnetic. For this, if you have a small magnet at home, take your magnet and try and stick it to different material like aluminum can, steel, iron, plastic, glass, and see like which material sticks to the magnet and which doesn't. That'll tell you which materials are magnetic and they have magnetic property. This could be difficult for you to do the experiment at home because you may not have the wires or the copper wire that you need to turn around the iron, which is the magnetic material. However, you need to understand few points here that, like, look at the picture on page 53 and look at the two batteries. One's got 20 turns, one's got 50 turns, and it's a battery which is connected to two wires, and those wires are connected to a magnetic material around which the copper wire is turned. One's got 20 turns, one's got 50 turns. And if you look closely at the picture, the one with the 20 turns, it's attracting, it can hold one paper clip, whereas the one with the 50 turn can hold two paper clips. What does it mean? That means that the wire with the 50 turn has a stronger electromagnet as compared to the wire to the battery which has the magnet with 20 turns. Look at the picture at the bottom. Now, in the top picture, you have a iron nail which has magnetic property, which can attract a magnet and the current flows through it. Whereas in the bottom picture, if you see, the nail is absent in one of the picture, and in the other picture, the nail is present. And here we have the same number of coil wire, the same number of turns, and we can see that where the electromagnet, the iron nail, is present, it can create a much more powerful magnetic field around it and can hold stronger, whereas the one picture on the left where there is no nail has a very weaker field around it. In this slide, we'll click on the link and we'll watch how maglev train, that means magnetic levitation trains, are constructed, what is the science behind these trains, and how magnets help in running the train. These trains are without any wheels, and how do magnets propel the train at such a high speed? As part of your homework, I want all students to try this experiment at home. It's called magnetic propulsion. It's like designing your own small maglev train. What you need is you need a toy car. I'm sure all of you have a toy car at home, and you need 3 bar magnets which are like long thin magnets, bar magnets. Try to find magnets and just follow the steps 1, 2, and 3. It's pretty simple and can be done at home. Now, if you need further information on how to do it, if you're a little confused, just type it in Google, find experiment related to magnetic propulsion, maglev train. You'll come across a lot and you can use those as a reference. Now, as I said before, I want you to do the experiment, record yourself, and publish the video. Thank you.